Okay, let's talk about the parameters and return type of function pointers. So, well, it's not that difficult thing. So, if you want to use a parameter for function pointer, just use it. V maybe, but you should use the same parameters to the functions you would like to use for the pointer, and it also requires some parameter. If you want to use one more variable, do it. It's not that difficult. Okay, so do it. And you need something like this. And for return type, well, use your return type if you want. So we don't need, well, float answer. Maybe or not. It's not important. Instead, you need this. You should define return value here. So it's easy. It's not that difficult. Okay. So it was the question, right? No? What was your question?
함수 포인트를 3줘서 그 함수가 EX 함수가 그 지금 3도 변수가 없잖아요.
여기 요 함수가
예, 그 참정 변수 없잖아요. 괄호 안에서 변수 없잖아요.
여기 변수가 없죠?
예, 만약에 거기서 펑션 포인트 여기서 추가하면요.
그거 재밌는 생각이네. 자, okay. Let's undo everything for the simplicity. Okay, we know that it's gonna work. So let's just end on something. Okay, so let's begin from here. So you are talking about using a function pointer as a parameter. 이 얘기지?
네. 그리고 맞습니다.
Right? It was your question as well. Right? Okay, let's do this one step by step. So let's do not use the same name. Well, input function pointer maybe. Function pointer to avoid the ambiguity. Okay, so let's try compiling geometry. So in this case, we don't need it. Well, we can do this box. One more box here. Let's do this. Okay, it's working. Box 1 to 3. Box 4, 5, 6. This is a big difference. 1 to 3 and 4, 5, 6 because it's using this one, this A variable of this one. Okay, this one here and this one here. So this means that we can make more combinations of the class instance and function pointer. It's an interesting property. Okay, so let's go back to this execute function. Let's go to definition here. So the next question is this one. So, well, maybe you would like to use an input parameter like this one. So maybe pointer go, go, and you can use this pointer here. Okay, let me do this. You got it? So let's test it. If we build it, it's going to make an error, and my box here. So let's insert the pointer of this my box instance to exe function. And well, even if this is my circle, you can use this one. So let's try. Yeah, draw box 1 2 3, draw box 1 2 3. So you can make more combinations. Well, like my circle. In this case, this one's going to use the variable a of this my circle instance, and it was 4 5 6, and it's calling draw box function. So let's do this. Draw box 4 5 6 4 5 6. Even if the caller instance is my box and my circle, right?
그리고요, 그 exe 함수, 그 참조 변수가 지금 그 함수 포인트 아니고요, 그 word 포인트라는 함수.
뭐라 요거요? 요게?
그 exe
요게?
이 함수 참조 변수가 지금 만약에 지금 함수 포인트잖아요. 그 함수 포인트 쓰지 않고 그 word 포인트 쓰기 되면
워드 포인터?
void, void.
보이드?
그거 쓰게 되면은
여기다 보이드를 넣자고? 아, 그러면
그리고 호출할 때 그 함수 포인트 거기서 보내면 뭐라 해야 되나?
보이드? 그러니까 여기다 요거 넣자는 거 맞아요?
포인트.
어?
void 포인트.
널 포인터 얘기하는 거예요? 널 포인터?
포인트 아니고 제가 써보세요.
쳐봐. 초로 나와서 코딩하는 남자였을
죄송합니다.
죄송할 거 없지. 내가 편하지. 키보드 안 만지는 게 좋겠네.
만약에 이 포인트 쓰게 되면 여기서 얻은 이 함수를 뭐지?
앉아서 해, 앉아서. 나 코딩 안 하면 좋아요. 내가 지금 목에 디스크가 두 군데가 있고 허리에 하나 또 있어요. 이게 다 코딩에서 얻은 거. 지금 초등학생들부터 코딩 교육 시키라고 하는 애들을 다 디스크. 안 돼. 앉아서 천천히 해요. 시간도 안 하거든.
거기서 빨리 할게요. 여기서. 그래서 이거고요. 지금 이 함수 있잖아요. 이 함수를 여기서 이 프린트라는 함수 안에서 보내고 이 지금 이거 보이 void 포인트잖아요. 이 void 포인트를 그 함수 포인트를 변할 수 있나요?
해보면 되잖아. 주석 처리한 거 지우고.
그거는 이거 제가 해봤는데 잘 안 돼가지고 그래서 여기서 주석 빼고요.
아니 VP가 여기 뭘 하고 싶은 건데 거기서
여기서 이게 아니고요. 만약에 여기서 어떤 함수 포인트가 여기서 보내면요. 여기서 호출할 수
펑션을
있게.
거기 꽂아놓고 싶다고?
네네 맞습니다.
잠깐 내가 알려줄게. 거기
이렇게 쓰시면 제가 목적이 이렇게 쓰시면요. 그래서 함수 한 번에 정의하고 모든 함수 포인트 다 보낼 수 있게
이렇게 이걸 하고 싶다고?
네. 이거 만약에
펑션이 있고
예.
펑션은 근데 밖에 정해야 되니까 빼고 그지?
네 맞습니다.
이건 필요 없고 그다음에 가서 앉으세요. 이걸 하고 싶은 거지. 그 다음에 이 함수가 하나가 더 있고, 근데 얘가 함수의 포인터를 받고 싶은 거죠. 함수의 포인터를 받고 싶은 건데 원래 이렇게 해야 되겠지?
네, 원래 그거 해서
이렇게 해야 될 거고, 그 다음에 이렇게 원래 해야 되겠지, 그지?
네, 맞습니다.
이렇게. 그 다음에 프린트에다가 펑션의 포인터를 바로 꽂아 놓고 싶은 거지, 그지?
네, 맞습니다.
이렇게. 근데 왜 안 되지?
언더바.
아, 이거 빼서. 근데 문제가 생기는 게, 아이 뭐야, unexpected 파일, 이거 뭐야? 아, 이건 됐고. 요건 되죠? 요게 되는데, 여기서 뭔가 변화를 원하는 것 같은데? 뭘 원하는 거예요?
그 Y 포인트.
어?
아까 그 포인트 제가 그 포인트로 보면요.
지금 원하는 게
네, 여기서 그 참조 값이가
여기에다가 어떤 함수든지 꽂아놓고 싶은 거지?
네네 어떤 함수든 다 꽂을 수 있게.
그러니까 예를 들면 얘가 있고, 그지?
네,
펑션 2가 있는데 이걸 넣고 싶은 거잖아.
네 맞습니다.
something 2. 그런데 얘는 타입이 이러니까 안 맞잖아, 그지?
네 맞습니다.
그래서 요거를 넣고 싶은데 에러가 날 거라고 펑션 2를 넣으면은. 여기 맞아요? 요거를 해결하고 싶다고?
네.
일단 해결 방법부터 설명을 할게요. 요게 펑션의 포인터죠. This is a function pointer to void type, but he wants to use the function pointer of this type. So we can cast this function pointer to this type. 어떻게 하더라? 몇 번 해봤는데. Okay, let me check my personal GitHub library. I have done this one for the other purposes. So, engine level draw, utilities, general, parameter, generic, not this one. Interface function. Okay, casting. Okay, reinterpret cast void. This one. This is what you want to do. Okay. So, for this one, you can cast. You can cast this one to a void type pointer. I think. Right. You are casting function pointer to a different type. Okay, I show you an example. So maybe you want something. You have an integer here, and you have a float pointer. P float. So this will fail. This is integer, and this is a float. So you can force casting in this way. Well, you can interpret cast or something. I don't remember exactly. Maybe this one. Dynamic was. So I don't remember the exact casting operator, but you can. There is a grammar about this one. I don't. Maybe type. Maybe integer a is a pa. Okay, this one should be pointed, right? We can do this. You can cast memory address to a different type. So not this one. So we are doing same thing for function pointers. You got it? Got it. Function 2 here. But it was casted like as if this one does not have a parameter. So I'm not sure about the successful execution of this one. So let's try. Okay, it's working. Well, do something 2. Function 2 was casted to void parameter function pointer. It's complicated, but it works. So you can do this, but I never recommend this one. Find different way. I know how to do it. Yeah, I know it works, but I do not recommend using this kind of tricks for the runtime implementation. It was your question, right? So maybe you can recast this one to the original type like this. It's going to work. And 1 to 3 maybe. It's going to work. But this makes programmers very confusing. So I never recommend doing this one. You can do this. Well, you can cast any pointer to a void pointer, like this one. You can do that. Oh. But the way your compiler stores integer or float, integer and float are quite different from each other. So no one can guarantee correct execution. So this is very dangerous. I don't recommend this one. Or maybe, well, I'm not sure, but frankly speaking, I use this one for my personal project. Yeah, but it was very difficult. It was not a good approach, I know. But sometimes, well, there is no more choice, then you can do it. That's why this exists in C++ grammar. Yeah, this is a very good question. Yeah, this is a good question, and it's going to help your understanding very much. Okay. Okay, so let's go back to our original topic. So we can do this. We can do this. So we are free from using instance pointer, instance and the function pointer. So we have great freedom, and this kind of pattern is called the command pattern. This is one of the design patterns. Okay, if you are not familiar with design patterns, okay, so if you want to be an experienced programmer, you need to study design pattern, and I think I taught you factory pattern 2 weeks ago, maybe. Yeah, and here is one more thing. I think there are 32 patterns, and well, now understand 2 patterns. So command pattern. Let's rename this one to command maybe. Well, the function name is not important, so you can use any name you like to use. So it's not that important, but well, I want to use this name command so that you can know that this kind of approach is a part of command pattern, the famous one. Okay, and now in this time, let's go back to the definition of command function. So in this case, this command function does not access the instance directly. In this case, this pointer was used here, but in this case, well, all of the information are from this one. So maybe we can use static function. Okay. So, and one more thing. Maybe we can use class name here to represent that this command function is independent from any of instance. So it's very clean. Well, we have command pattern that is independent from any of instances, and you are free to use any instance of geometry object and any kind of operation to as an input of this command pattern input. So it's working as we expected. Okay. Okay. And well, we studied command function, factory pattern before, right? So maybe we can use the similar thing. Well, about this one, we are doing this one. This is a kind of factory. This one is making my object behave as a box, and this one is for circle, right? So maybe we can make one more factory. Void factory get pointer right, and let's just use if time name is box maybe, right? Okay, we need to return the pointer, right? Pointer. So if it is, so geometric object, new object is new. You can do this, or maybe you can use auto, right? And new object was generated here, and its callback should be okay, pointer. It's working, right? What's wrong here? New must have. Okay, it's okay now. Else if type name circle. Right? And if we don't have enough correct type name, then just return null pointer. This callback is initialized as a null pointer here, and we need to place a safety device here. Callback. Oh, we don't need this one here. Instead, we need to check assert. Well, we need something like this one for the safety to ensure the correct operation. Okay, and let's return new OB. So we have a factory. We have a factory, and as we did before, we can use a. Okay, let's remove them. We can define a vector or list geometric object pointer. We need to use list here, ngo list. So go. Okay, and one more thing, we can define this function as a static function, right? Okay, so go list dot push back and geometric object get pointer, and maybe we want a box here, right? Go list dot push back circle. Okay, we have a command function here, but we don't. Well, let's implement execute again. Okay, so let's use this one. Okay. Okay, so for title, go list. Auto. Execute. And we can do this or to delete everything after we do this. Okay, so this is a kind of factory pattern. So let's try. What's wrong? Let's break it. Okay, something's wrong. New object, callback, throw function. Okay. Maybe we need to add some define maybe 1 to 3. Sign up and draw box, draw circle, Okay, let's start debugging. Okay, start debugging. Break, and let's go to here. This case iterator is okay. So this, let's see this pointer. A is 1. Callback is a null pointer. Stop. Okay, maybe we were going too fast. Okay, so let's do some debugging here. So let's place a breakpoint here and debug, start debugging. Okay, so let's go step inside. The short key is F11 and I think step into is this one. Step into, ignore this part, press F10, one more F11, then we are here. So we generated a new instance of new object and the input type was box. So we are correctly initializing the callback function, right? We have the callback, the address of a callback pointer is not a null pointer, so it's okay. Press F1, F10, press 11 again. Let's ignore this one. F11 again here. In this case, the type name is circle, and I found a typo here. So let's stop debugging. We found the region, circle. Okay. So let's execute again. So it's working. Okay, let's go back to clean version. Okay. Okay, so it's working correctly. Okay. So today we studied pointers, the variable pointer. I briefly reviewed some pointers, and well, more importantly, you studied function pointers, and you also studied some design patterns, and now you understand, I hope you understand the relationship between the function pointer and the more important polymorphism.